Hello, and welcome to our webinar, Controlling and Measuring Color on Metallized Surfaces. My name is Monica Baptiste, Marketing Manager for the Americas at X-Rite, and I will be your webinar moderator. Before we begin, I want to go over a few points with you. Because of the number of people attending today's webinar, we will keep everyone muted. I ask you to please use the question function on the GoToWebinar panel to write your questions as we go. At the end of the webinar, we will have a Q&A session. This webinar is being recorded. You will receive a link to the recording of this webinar so that you can review it at your convenience. Our presenter today is Raf Mulla, Solution Architect at X-Rite Pantone. Raf has worked directly in the field of color for over 12 years, and much of the last few years have been spent supporting a wide variety of customers in their attempt to capture, quantify, qualify, and formulate color across a huge range of industries, including the traditional fields of print, paint, textiles, and plastics, as well as some of the more novel ones such as cosmetics. Currently, Raf is part of the X-Rite team focusing on bringing color solutions to the entire packaging arena using digital color measurement throughout global workflows. Hello, Raf, and welcome.
Hi there, thank you, Monica. And again, I'd like to welcome everybody to the webinar on color control of print on metallic substrates. Thanks for the introduction, Monica, and for moderating, and thanks to everybody for taking the time to attend. What I'd like to do today, and you can see in front of you the agenda overview. What I'd really like to do today is to look at some of the key topics to consider when measuring print on metallic substrates, and look particularly at some of the challenges, and look particularly at how instruments capture the data and what the best kinds of instruments to use to get good color measurement data in this arena are. As you can see from the agenda, there's quite a bit to get through, so I'll get going without further delay. Just to start with, just for the people who are not familiar with X-Rite, just a quick overview of who we are. We are the global leader in color communication. We are present wherever color accuracy is a requirement in industry. We work across fields from aerospace to cosmetics, from textiles and fashion to fabrication. We are where colour is at. We have a great deal of expertise to share within our organisation and across our organisation. I'd also note, for the people who are not familiar with it, that Pantone is a wholly owned X-Rite business, which also allows us to access colour at the point of creation. So our goal here is really to help control colour all the way through from inception to actual delivery, and that's really what we're focused on. Within all of those arenas that we deal with, packaging is clearly a significant one. It's a key area for us, and within packaging, greater and greater emphasis is being placed on appearance of the packaging to sell the products. Market research shows that up to 65% of a purchasing decision involves colour. So colour is a key brand asset. It's a key player at the point of purchasing decision, which means that it impacts how successful a brand is. It impacts how successful a product is, both in the short term and ongoing. That means that printing good quality, consistent, and I'll use the word predictable because predictable is very important here. People need to understand what they're going to get and how to get there. But printing good quality, predictable colour on packaging is significant to a product success. Most sectors in packaging have already recognised that the only way to achieve this for colour is to use colour measurement instruments, spectrophotometers, to catch and digitize the data. And I'm sure that many people within the packaging arena have already come across that. Metallized substrates, of course, play a key role in the packaging sector, not only offering additional strength and protection to a product, and of course some products simply could not exist without metallized substrates, but they're also used to convey value and premium quality. Controlling the colour of print on metallized substrates is therefore key to maintaining that perception of quality, and that really is a key focus for us. It really is a key element as we move forward, and hopefully for all of you that have joined out there today as well. What makes it different? Why is controlling colour on metallized substrates so challenging? Well, the first point to note is that by their nature, metallized substrates are highly directional in the way that they reflect light. And for many years, people have relied on visual evaluation to control these. Now, because of the directional nature of the material, what you view depends very, very much on the angle that you view the printed material at. So this means that consistent visual assessment of colours is even more difficult than usual. And when we talk about even more difficult than usual, that means that not only do we have to contend with any of the elements that make colour control visually difficult, the idea of communicating colours verbally, it's very difficult. The ability to recall and retain colours in memory is very difficult. Now, if you add into that the difficulty on metallized of controlling angles of both illumination and of evaluation, so not just where you stand to look at it, but where the light is in relation to the substrate is key. That makes it very, very difficult to get consistent visual assessment. And I'm going to use the word consistent throughout the presentation. It's very important. It makes a big difference. And when we're thinking about this, one of the things I'd like people to consider, and one of the areas that we've worked on, are things around speed of decision making. So if we are concerned about a consistent presentation visually, what does that do to our ability to make decisions quickly in production? What does that do to our ability to then communicate the decisions? It looked okay when I held it at this angle, and I'm sure that there are many people listening to this who've spent an awful lot of time tilting metallized substrate samples backwards and forwards to get them in just the right light to be able to make the decision. And that's not only difficult to make repeatable, but it's also very time consuming. The other element within that is the repeatability of the decision. And when I say repeatability, that's not just whether one person can take the same decision over and over again, but how easy is it for people to take the same decision over shifts, to take the same decision over different plant locations, over different continents, over different suppliers and customers. So consistency within all of this is very, very important. To look at the consistency, what I'd really like to do is understand the different types of instruments that we have to measure colour, and just like to take a couple of slides to look over that. There are typically considered to be three main categories of spectrophotometer, and the categories are based on how the instruments capture the light. So there is, or there are multi-angle spectrophotometers such as the X-Rite MA98. There are 045 spectrophotometers such as the X-Rite Exact, and there are spherical spectrophotometers such as the X-Rite CI64. In fact, the multi-angled instruments are not widely used or widely found within the packaging arena. They typically require a significantly larger area to measure to get reliable results, and are not and therefore not easily applied to pieces of finished packaging where such areas don't normally exist. And for that reason, really what we're going to do is we're going to focus on 045 instruments and sphere instruments. If we pause and look at 045, 045 instruments are the kind which are most commonly found in packaging. So this is your traditional colour measurement instrument found within most areas of packaging, and they're called 045 because the light is collected at an angle of 45 degrees to where the lights hit the original substrate. That's excellent for traditional materials, paper and filmic based materials, but that does mean that there are very, very significant challenges on metallized substrates. And I'd just like to take a moment to have a look at those. Because metallized substrates reflect light in a directional way, much less information is captured by a 045 instrument optics. So and I hope you can see my cursor move across the screen. I'm not sure how this broadcasts in a webinar, but as the light comes down, the closer a surface is to a mirror finish, then the less light is actually captured as a result. And the closer the instrument, this is a 045 instrument, the closer a 045 instrument will read the result as being black, an absence of light reflected. So if you actually measure a piece of metallized foil or a metal substrate with a 045 instrument, chances are you will get a result that almost reads as black, which is very, very, very counterintuitive. The result's actually complicated in some senses by the application of ink to a metallized surface. So as soon as you start to add ink, you increase to a small degree the amount of light that's going to be reflected and captured by the instrument, and that degree is highly dependent on the transparency or the opacity of the ink that's been applied. So that gives us an additional problem, because now the amount of light collected and the way that it's collected depends also on the opacity of the ink. So you could make, in theory, the same ink colour applied on paper, two different formulas. Those formulas would possibly give you very similar results on a paper-based substrate, but on a metallized substrate where opacity becomes much more significant, you're going to get very, very, very different results. And that means that it becomes quite difficult, very, very difficult to control colour using 045 instruments. I have seen instances where a job's been on press, it's a 3 or 4 colour job. The press operator has gone to measure the colours using a 045 instrument. Two of the colours have returned numbers that seem to make sense, that give some indication of the colour underneath, and two of the colours have pretty much read as black. And that's a very, very, very difficult thing to police. It's very difficult to control it consistently. It's also very difficult to train people on a production floor how to deal with this and how to operate with this properly. Some people have tried an approach, and some companies have tried an approach of trying to hide the substrate underneath by printing a white. So effectively, you have your metallized substrate, you have a white printed over the top, and then you put your ink down on top of the white. This, the effectiveness of this depends entirely upon the opacity of the white applied and the colour of the white applied, of course, and the ability to consistently apply and coat with the same opacity white. In reality, in practice, it's a very, very difficult thing to control repeatedly across production runs, across factories, and across different locations. And a number of people have tried this. It's not an easy thing to do. The other category of instrument that we want to look at are called spherical spectrophotometers. And unlike 045 instruments, spherical or sphere instruments can capture all of the light that's reflected from a surface. This means that the mirror effect of the underlying substrate causes no loss of reflected light. So now we're capturing all of the light that's reflected from the surface. With the 045 instrument, we're capturing the light at a specific angle. And the fact that all of this light is captured makes these instruments ideal for metallized substrates. And in fact, if we look at modern spherical instruments will normally capture two measurement types with each reading. So we're not talking about two separate readings here, we're talking about one press of the button delivering two different types of data. First type of data is called specular included, or spin, which consists of all of the reflected light. The second type of data is called specular excluded, or specs. Occasionally it's referred also as SCE. And that is the data, that's the light reflected with gloss component subtracted. That makes it look a little bit more like a 045 measurement. The two measurements don't correlate, but what we now have is from a single button press two measurements. A spin measurement, specular included, and a specs measurement, specular excluded. And there's a graphic on screen there which hopefully shows the top bar would be specular included. Okay, and you can see that it's lighter. The bottom bar, specular excluded, because we've taken away or subtracted that first gloss reflectance. Now, most people and most specifications that we come across and are used within industry contain the spin measurement. That's because that's where you get maximum consistency, maximum reflectance of light. However, bear in mind that with modern instruments, you can capture both measurements, and this gives us quite a lot of power when it comes to some additional calculations that I'll talk about on the next slide. If we can capture this data, and numbers are great, I'm sure we all see enough numbers, and numbers are very good to deal with and manage. Let's have a look at what we can actually do with them. If we have a reliable colour measurement method, and that's what we believe that the sphere instrumentation brings to this arena. If we have reliable colour measurement, then it helps in a number of ways. Firstly, we can meet customer expectations. Once a standard's captured, agreed, digitised with a spectrophotometer, then that same standard can be used consistently across sites, across production runs, across globes, and we've a huge reservoir of experience now of using standards captured on metallized substrates, distributing them and having them matched to with great success and great effect. The capture process does have to be managed, so there are some things that should be documented when you capture standards with on metallized substrates. Aperture is a particularly significant factor, but as long as you follow some very simple documentation and some very simple procedures, then the ability to capture and digitize standards on metallized substrates is not an issue at all. Once you then have your digital standard, of course, the production efficiency then runs from that and then flows from that. So by using a consistent standard, that means that ink recipes can be rationalized because you're always working back to the same point. On-press correction should be minimized because we're going to a known standard, because we're going to a fixed point. Typically, the inks will be brought to press ready because there's a lot less guesswork. We're not going to have to tweak based on some visual interpretation at the side of a press. One of the things that tends to do is it tends to mean that the guys who are producing ink recipes and ink formulations no longer have to compensate for variances in production. So the guys deliver a consistent ink. They deliver consistent ink consistently to press. It goes on press, and this allows people to then look through their processes and understand where the inconsistencies really are. If the same ink's being delivered every time, then you'd expect the performance of that ink to be the same. If there's any change, it's likely to be production variables. And that in itself is a great help in avoiding the proliferation of the number of inks that people have to carry, where they are actually reformulating to correct for variations on press and production rather than variations within the ink. Of course, we can then control variations. Being able to check color variations numerically means that you can monitor something through a process. You can add in your own check limits. You can add in your own maximum thresholds. You can correct for color. Delta read typically is what people will correct on. Shifts in hue, shifts in lightness. All of these things can be tracked, quantified, trended, and typically we would do this with software. Most of the people I've seen using these systems successfully are using it with software. It really does bring a range of added benefits that you can't get from a simple handheld instrument display. And if we have a look, using the software also opens up some additional options that maybe people are not quite so aware of. So particularly for metallized substrates, using software opens up the option to capture things like whiteness. So you can use the data, and this is not a separate measurement, this is part of the measurement process. You can capture whiteness, which helps you both to define and control any bottom coating, any unprinted coating, but also where that's a significant part of the image, that also helps to control that. We have opacity measurements, which again can be particularly important on metallized OPP. So by measuring an ink over a white background and over a black background, a measurement of opacity is possible. And again, you're building a metric, you're building a consistent point to work from. If something changes, you can evaluate, you can say, my opacity's changed, I need to deal with that. Or maybe I need to reach a specific opacity in order to be able to hide the background or to be able to produce a required visual effect. Ink strength measurements is another area where spectrophotometers, along with software, have proved to be particularly useful. There is still some evaluation work, there's still some exploration work of how this applies on metallized substrate, but certainly people have started to look at this, and some people are using this quite successfully to be able to understand where a variance in a print lies. Is it a color variance? Is it a simple shift in color? Is it a shift in color strength, which may be then relates back to film thickness? And we've actually seen this used as a far more effective metric than when people have used things like density. So we have come across people still using some old density-based measurements on metallized substrates. Again, using 0.45 instruments, really not suitable. Looking at strength options is a much preferred option for trying to gauge film thickness. We also have something else. We have the ability, by combining the specular included measurement and the specular excluded measurement, to do some investigation into gloss levels. And again, some companies have already begun to apply this quite successfully. Again, remember that you have a single measurement, and now you're getting two pieces of data. You can compare these pieces of data to give you some idea of what the level of gloss is. The greater the difference between the specular included and the specular excluded measurement, then the greater the gloss effect has been. You'll remember that the specular excluded measurement removes the gloss component from the measurement. So the greater the difference between the two pieces of data, the higher the gloss effect. And people are starting to look at this and to use this with degrees of success. We've also seen spectrophotometry using sphere instruments successfully used particularly in three-piece metal deck, where people are doing multiple passes of colours, and they want to control the ink film thickness on each pass. So they'll run a sheet through, they'll measure on a specific, they'll measure a specific colour and colour strength, so that they can have a control place for the next hit. So if you're doing a double hit of a colour, a red, a blue or a black, and you need two hits, again, by controlling each part of that using a spectrophotometer, you're likely to prevent having to overcompensate or undercompensate with that last film thickness. Again, the uses of spectrophotometry in this area are really quite widespread. We've seen people use it for counterfeit control, so using specific spectral curves, using specific pieces of spectral data to be able to reduce or to increase the difficulty of counterfeiting and to improve the overall global consistency. And again, once you improve that consistency and have tighter specs, it becomes harder for other people to match that unless you want them to. So there really are a whole host of things we can do with our colour data once we've captured it. The conclusion, well, metallized substrates are a key part of the packaging sector. I think we'd all be agreed in that, because of the premium nature, and also we should not neglect material cost. Controlling colour is very important. Waste minimisation is key in this sector. There are three main types of spectrophotometer that could be used: multi-angle, 45-0 and spherical. But because sphere or spherical instruments capture all of the light from a metallized surface, they really are the ideal choice of instrument for measuring print on these surfaces, and they would always be our default or typical offering when dealing with print on metallized substrates. This allows us to have consistent color measurement and control, but we shouldn't forget that using these sphere instruments also brings us some extra metrics that we probably otherwise couldn't have, particularly things like evaluation of gloss, specular included, specular excluded. That pretty much concludes what we'd like to go through today. I would like to, again, thank you for your attention. Thank you for logging on to the webinar. I almost said tuning in there. I'd like to thank you for logging on to the webinar.